Thanks, Marco. Good morning, everybody. Really nice to be here today in what is a pretty cool venue. My name's Tom Spencer. I'm Director of Customer Data Sciences with Aviva. And what I'd like to do today is talk to you about how we've transformed our people, process, and technology to help us deliver a transformation in the return on AI we can deliver to our business. But before we get to that, I thought I'd introduce Aviva. I'm kind of hoping many of you know Aviva already, a big yellow brand. Maybe you've got car insurance with us. I was going to do a show of hands who's got an Aviva product. Actually, many of you may not know you have an Aviva product. We're one of the UK's largest workplace pensions providers, and sometimes people don't always know who's providing that for them. But we have a really wide range of products and services. We're the largest insurer in the UK. We've got 16 million customers. And we're pretty unique in terms of the breadth and range of services that we offer. And let's zoom in to just one of those. So motor insurance. There's a bit of a car theme through the presentation today. And you can see, even under what seems like a simple product, we've got many different flavors, from car, multi-car, electric, van, commercial, temporary. And what if we zoom back out again, back into that whole product ecosystem? You can see we have a really diverse range of products and services with which we can serve our customers' needs. And for me as a data geek, I'm hoping many of you, that's a really exciting proposition, because that means we've just got some incredibly rich, deep data on customers. And that's just talking about our products and services. What about if we look at the touch points we have with our customers? These are just some of our digital touch points on our newly relaunched MyAviva app. Hope many of you are enjoying that at the moment. Something we're really proud of, our website, obviously. But actually, we've got one of the UK's largest contact center operations here. So we've got all of those rich conversations and interactions with our customers. We sell through banks, through intermediaries, through brokers, financial advisors. I've talked about our workplace schemes, our employee benefits, and that's not to mention our investment arm, our commercial lines, our specialty. So all of that just gives us incredible data, and it helps to explain why Aviva is such a great place to work in data if you're interested in customers. However, there's a bit of a problem. Is that a holy grail or is that a poison chalice? Because with all of that great data, with all of that complexity, we get a significant amount of challenges. Organizational complexity, legacy technologies, legacy mindsets, silos, even politics, believe it or not. And all of that means that driving change at an organization of our scale and many of your companies is really bloody hard. And I was excited to see the System 1 story because they're working at such great pace. But for us at Aviva and for my team, that challenge means that the payoff is much greater, because we've got the chance to make a difference to the lives of tens of millions of customers and their families, being there for them when they need us. And we can make a difference to one of the UK's largest organizations. So it's definitely worth it for me. That's not to say it's easy. My team's called the Customer Science Team, and we're a bit unusual in that we don't work on the traditional insurance analytics problems you might expect. We've got other teams that focus on understanding risk and pricing. We focus on customer, and using all of that data, my team of analysts, data scientists, engineers, and product people help us understand customers. And then we can be really relevant to those customers and build a better experience for them and generate better customer outcomes. We do that in two main ways. So the first way is data analytics, so that we can really understand customers and create actionable insights that we can then support people make better decisions. And that might be the high-level strategic choices we need to make at our exco or board level, right the way down to really granular tactical trading decisions. The second thing we do is build AI and machine learning data products that we then integrate into our system so we can drive that value, that relevance, that improvement at scale. We've been a client of DataIQ for, since about 2017, so I think we're one of the earlier clients. Very happy clients, I'm pleased to say. And through through our work, we've been able to drive tens of millions of pounds of return on our work in AI and analytics every single year. And we've got really great stakeholder feedback, great team engagement scores, and we're award-winning over several years. So we're really proud of what we're achieving, but we're not complacent. I certainly don't think we're brilliant, and we've got a long way to go, and we had a long way to go. And I'm going to talk to you about some of our story, starting from a couple of years ago, because, like I've said, driving complexity and legacy, driving change in complexity and legacy is hard. It takes time. And our team used to be too slow. Dealing with all of that challenge, we had too many different ways of doing things, not enough automation. We had too many handoffs, not enough process. And if we were just too hand-cranked. And if we cranked the handle, you can see our machine learning lifecycle used to look a bit like this. So it was quite traditional, it was manual, and it was interactive. We had development disconnected from operations. We had too many manual handoffs from our scientists and our engineers and our technology teams. We had minimal automation, too much manual work. We had releases that were infrequent and large, and anybody who works in DevOps knows that's not a great place to be. It introduces a high degree of uncertainty in your releases and risk of failure, and when things inevitably do go wrong, a lot of running around to fix it. And we relied too much on talented individuals to do the heavy lifting. And that's a problem for a couple of reasons. The first is that's just not scalable. We can't multiply them. But also it introduces a large amount of key person dependency. So if that person were to leave the company, change project, we're in a whole heap of trouble. And that played out in the statistics. So I thought I'd be open and honest. There was lots of opportunity for us to improve. If we look at the time it was taking us to build a machine learning model from live and get it into production, it was taking 2 to 3 months. Deployment success was a coin toss. And as I've said, when things go wrong, there's a whole heap of running around to try and fix that. Weekly scoring wasn't much better. And our unit test coverage, although actually it wasn't zero, it was minimal, it certainly wasn't systematic. So back then we had a long way to go. Now what's kind of interesting is that our model performance was really good. We were great at machine learning, but just looking at those stats, it was clear that we had a problem. So we had to step back. And the good news is that this is a solved problem. Many of your organizations might be something similar. You might have been on a similar journey. It's a solved problem, and all we needed to do was look back. So look back into the past and take some history lessons from some different fields and apply them to our business, our teams, our problems, our context, our constraints. We knew the solution lay in machine learning operations, or ML ops. And many of you will be familiar with ML ops, but really it's a set of practices that allow us to automate and streamline the machine learning lifecycle. And it learns from and borrows from software engineering and DevOps to help us build, test, deploy, manage machine learning in production reliably, safely, and at scale. It includes things like version control, so that we can track changes in models, code, and data. So we've got reproducibility and auditability through our system. Automation, so we can get speed and control all the way through the life cycle. CI/CD, which is something called continuous integration, continuous deployment, which is a set of practices that allow us to continually test and release in a scalable, reliable way and consistently. And finally, monitoring and governance, so that we can make sure we're compliant with regulatory requirements, with governance, and with best practices. So like I say, the solution was out there. We needed to bring that in and apply it to our business. So how did we do that? Well, it's a classic people, process, technology problem. For the people in process, we created a project that we call Kingmaker. Why did we call it Kingmaker? Well, we started around the time of King Charles's coronation. giving us a little wave with his poppy there, very, very timely. So I thought that was a great idea, very topical at the time, like the name. My AI and machine learning lead loves indie music, and he thought I was talking about this floppy-haired English indie band from the 1990s. But whatever the reason, the name stuck, so we went with Kingmaker. And on the technology side, I'll talk to you about that, we started a project that we called Dataiku Step Change. And we started a program of work together with working with Dataiku partners, with our technology teams, with my teams and with our change teams to make a change to our technology. I've talked about the challenges, the complexity, the legacy that we were dealing with. That means that driving change can be slow. We knew we had an awesome platform in Dataiku. We also knew we weren't getting the best from that platform. And a lot of that problem was on our side. That was an Aviva problem to solve. It wasn't really a problem with the platform. Our platform was at capacity. We were hitting compute bottlenecks all the time, every day, outages, jobs failing, jobs queuing, some pretty annoyed scientists and engineers. We couldn't easily collaborate. We didn't have the best practices around CI/CD. Deployments were too manual. I've showed you that interactive machine learning lifecycle with too many handoffs and manual tasks. And many of our packages were out of date, so we were working off old versions, which meant that we couldn't take advantage of the latest features. So, as a team, a cross-functional effort, we invested time, money, and energy into driving change through our estate. One of the biggest things that we did was introduce Kubernetes and containerization, which gave us massively scalable compute. That removed the bottlenecks that we were seeing almost overnight, and we saw some incredible performance improvements in terms of our jobs running in half the time, almost immediately. So that was incredible, and our technology teams had access to a new range of tools to help them work together with us. We brought in Git so we could properly version control, auto-deploy so we could start on our CI/CD journey. And we upgraded. So we upgraded from Dataiku from 9 up to 12. We upgraded Python, Spark, and a whole heap of other tooling in our ecosystem. Whilst we were doing that, we took the time to clean up our estate. So we took our code environments from over 150 right down to 20. We deleted out our projects, and that made our estate a whole lot manageable and easier to maintain. As we migrated our projects as well, we deleted loads of those, archived them, and we undertook a mass code refactoring of a scale rarely seen at an organization of our size, so that we could make sure our projects, again, were up to date, compliant, and building in the best practices. All of that work together as part of this step change project gave us huge scalability, and it also massively enhanced our risk and control environment. Thought we'd solved it, but we still had a problem. And as I said before, this isn't just a technology thing, this is about people and process. We still had this very manual, interactive machine learning lifecycle. We had a lack of standardization and automation, which led to inefficiencies and inconsistencies. There were challenges in collaboration. I've talked about adopting CI/CD best practices. We still had some way to go. Even though we'd proved some of the tech, we hadn't adopted the practices yet. And stakeholder confidence was low. So working together with our technology teams, working with our governance teams, they were struggling to collaborate with us. And our downstream stakeholders felt like they weren't getting the business value that we were setting out to provide, that return on AI investment that we wanted. And that's where Kingmaker came in. And a really good analogy, I think, for where we were is early car manufacturing. So this is an early car from 1904. It's not mine. And you can see, beautiful piece of technology at the time. But it took a really long time to build. It was labor-intensive, time-consuming. Each car used to be built by teams of specialists working on the same car from start to finish across a period of about 12 hours just to produce one car. Now, I think the end results are pretty beautiful, but actually, that type of handcrafting just isn't scalable, and that's a bit like our machine learning. So what did we do? Well, we took inspiration from this, the moving assembly line. Now, this is Henry Ford's innovation in car production, and when he introduced it in 1913, it radically reshaped the car production process. It allowed for the specialization of labor, so each of these individuals are working on particular tasks and repeating that on the same car at their stations over and over. It's a bit like early automation, I guess. And that allowed much greater speed through the production line. Instead of taking 12 hours to produce a car, it would take 90 minutes. And that speed of production meant that the costs could come down as well. It also increased quality. But the costs coming down meant that Ford could then sell their cars at a much lower price. And that opened up the market to a whole heap of the American population who previously couldn't afford it. So by that innovation in production, he'd radically reshaped an entire nation and dare I say it, the world. And that's kind of what we wanted to do. In our machine learning, we didn't need lots of bespoke, handcrafted, beautiful, perfect machine learning models. We needed lots of good enough models. We needed them live, we needed them in production and delivering business value on which we could then iterate. And the interesting thing to me, I think, is that we talk about MLOps. It's not really about the machine learning itself. And there's this seminal Google paper from back in 2014 talking about the hidden technical debt in machine learning. It's not really about the algorithms. The ML is just this box in the middle. It's a small fraction of the entire machine learning ecosystem. And what we need to do is work on the rest of the ecosystem, not obsess about the algorithm. And what's interesting with this, back to the manufacturing we talked about earlier, is it's a process problem. A large part of this is dependent on fixing the process. So that's what we set out to do with Project Kingmaker. A large part of Kingmaker was forcing standardization in what we did. The first thing we did was mobilize a small, cross-functional team of experts to focus on understanding and solving this problem. A bit like System 1 guys, again, talking about getting the right people working on the problem and allow them to solve it. We ring-fenced them so they weren't distracted by the day job, because to be honest, we were trying to do some of this before and it just wasn't landing. So by ring-fencing, we could create impetus and focus for that team. And then they set about mapping the entire end-to-end machine learning lifecycle, not just the code here, but our entire process. Once that process had been mapped, we could then force standardization through it. And after that standardization, we could then start to optimize and automate. But a really key point here is that you can't optimize and automate if you haven't standardized. That's got to come first, and that's straight from the manufacturing playbook. I kind of hope Henry Ford would be proud of us. So practically what they did was built out a standard framework. And under that machine learning framework, we built out a standardized Dataiku DSS project, with each of the zones representing the different elements of our machine learning pipeline. Now, I don't know if any of you are data scientists or work with data scientists. Perhaps you're married to a data scientist. Data scientists, in my experience, love to build bespoke things. They love building the best possible model using the best possible data for their very unique problems, their very special requirements. And this is coming, my background's hands-on as well, so I'm kind of talking about myself. But actually, the reality is the problems aren't unique. Often, you don't need a special model. So what we did was we forced constraints onto our scientists as well. And there's a bit of grumbling about that, I can tell you. But we forced constraints in terms of the algorithms that they could use, how they could use them, the feature set that they could work with, so that they didn't go off-piste all of the time. And once we'd done that, we looked at documentation, and we documented the entire end-to-end life cycle as simply as we could and forced standardization through that. We then looked at That documentation then gave us reproducibility and auditability, and it also went some way to removing that key person risk that I talked about before, where we've got talented individuals and it's all up there in their heads. And that's the simple formula. So through Project Kingmaker and through the step change work we did with Dataiku and our tech teams, we were able to address the people, process, technology triangle that we had to solve for. So if you add Kingmaker to step change, what are the results? Well, we were blown away. We weren't expecting them to be quite this good. So the end-to-end build time was going from 2 to 3 months down to days. Deployment success is pushing 100%. Scoring success, similarly. And our unit test coverage is now much more systematic, giving us much more confidence and control in our entire machine learning process. Taken together, all of those efficiency improvements mean that we can release 3 or 4 times the rate that we were previously, so which we think is phenomenal. And the thing we were really interested in was not only about the engineering challenges we'd overcome, but because of forcing those constraints and the standardization in the data science process, we saw a huge uplift in the performance of some of our models. And that was a bit of a surprise how good that was to us. But it's because everybody was working with the best in class we had. Everybody was standing on the shoulders of giants that had gone before them, using the best features, the best models, and getting a head start, rather than having to handcraft it from scratch and work on their own. Now, some of that collaboration was happening, but by forcing the standardization, it was happening now systematically every time. And with that, not only could we build better and build faster, we could also manage and govern our estates in a much better way, which is really important, which I'll come on to, is when we manage the scale and complexity that we can now introduce from this platform. So let's not forget our stakeholders, the people. How were they feeling? Well, I think the picture says it all. These aren't really them. But our business stakeholders were overjoyed, genuinely overjoyed. They could see the speed and the scale and the improvement of the value that we could deliver to them, the responsiveness they were getting from us. And our answer to their question, what have you done for me today? I don't know if you work with the business, that's quite a common thing. Our answer is always a lot more than yesterday. So they're over the moon, and actually working with our technology teams and our governance teams, they're happy too, we're happy, because we're working a lot better together and we understand where each other's coming from. And when we look at our team, I talked about some of the grumbling about forcing standardization. Well, actually, I'm pleased to say we've overcome the naysayers there. I talked about if you've worked with data scientists, some of them can be a grumpy lot as well. But actually, we are seeing smiles and thumbs up because we've massively increased the impact that they can deliver to their business and for our customers. Through this process, we've taken away a huge amount of toil and drudgery and just work that wasn't enjoyable and all the firefighting. Actually, now they can see that they're able to create their own legacy. They can see they're part of something bigger. Rather than working on their own project, now they're contributing to this greater whole that we have as a team. So we've been really pleased with it. I thought I'd leave you with a few key takeaways. And like I say, many of you will have been on perhaps similar journeys already, but I wanted just to call out what I felt were some of the key success factors for us. I think a major one, and I hope nobody at Dataiku throws anything at me, but it's not a tech-first problem. And actually, I would argue the bigger part of it is probably around people and process. Technology is super, super important. But unless you address your process, you won't be able to optimize, you won't be able to automate. So don't get carried away hoping technology is going to solve this for you. You're going to have to do a lot of hard, sleeves rolled up work. Force ruthless standardization. That's a really key part. We got some pushback, you'll get some pushback, but you've got to stay the course, otherwise you're not going to get the benefits. Partner to succeed. So you'll have to take people with you on this journey. I've talked about all of the different stakeholder groups, technology, governance, legal, working with our vendor partners. And actually, for many of them, this will be a new thing. They won't understand what you're trying to do. So help them understand why you're doing it, what you're trying to get, where you're trying to get to, and what you need from them. And I think also there's a learning that sometimes the semantics cause a problem because different teams and different functions use the same word to mean different things or with different nuance. So make sure you're clear on what you mean when you're talking to people. And finally, don't let perfect be the enemy of good. You've got to simplify and get good enough and get models across your estate because that's then the platform from which you can iterate and improve. Don't get stuck in a rut trying to gold plate because getting one good model live is so much better than getting a perfect model in development. And getting lots of good models live is even better still. So for us, what's next? Well, it felt like a history lesson looking back at the Ford assembly line, so I thought we'd look a bit forward into the future or the now. So this is a Tesla assembly line, and even just looking at that, you can see the level of automation, the speed, the control, the sophistication. So that's kind of our inspiration. And I think the really key thing here is we can now build on the momentum that we've got from Project Kingmaker and from our Step Change project. Okay, so that's not the end point, but what we've built in is the organizational agility and the capability to adapt to change. All of that hard work I've talked about before is the springboard for our future continuous improvement. So that's it from me. I thought I'd share some of our journey. We had to go back into the past to see the future of where we wanted to go to. We took history lessons from manufacturing, from software engineering, and from MLOps pioneers, and applied them into our big, slow organization and really drove change. So I hope you've enjoyed that. I hope you found at least some of that interesting, and I hope you can take some of that away. But what I've tried to do is show how we've driven change to increase our return on AI across people, process, and technology. Thank you very much.